Okay. Hey, hello everyone. Like this is gonna be like maybe some just more of a live coding instead of like the others were live coding more focused on Jackson Flags. This I'm gonna do like a little project, so it's going to be more on the translating minGPT from PyTorch to JAX. It, it's gonna be a little bit more challenging, and I'm just gonna see where I can get in maybe a couple of hours per week. uh, and I'm just gonna live stream it, so if people are interested to just watch the process in the future. um, so okay, yeah, first thing that I guess we should do. So yeah, I mean GPT is like a very popular repo right now. So the only thing is that it's like written in PyTorch by by Carpathy. So my idea was just, hey, let's just see how this looks in Jackson and Flax, and also maybe at the end, curious how easy would be to scale this up, given Jackson and Flax are a little bit easier to scale up, um, because Carpathy here created like nano GPT, whereas maybe in a Flax solution you don't have to do like you don't have to radically um, alter the code base, but yeah, who knows. So um, first thing, I'm not gonna clone it, I'm gonna fork it, and I'm just gonna call it minGPT-JAX. Yeah, maybe in lowercase like this. Uh, and let's just change it here to JAX. Um, so now I'm gonna clone this part. Um, let's see. So I already have like, yeah, I'm gonna clone it, and I'm going to mean GPT JAX. So this will be initially the same environment as in the like the PyTorch version, but I'm gonna do some adaptations, like based on my personal workflow. So I like to use poetry, so I'm just gonna set up like a poetry environment, poetry init, I guess. Uh, no, no. Yes. Okay, so I think, okay, it only depends on Torch. So I okay, I think for reproducibility purposes, I'm actually going to install PyTorch in this environment. But obviously, also going to install JAX. So triad JAX, JAX lib flags, and torch. I think that's going to maybe be the dependencies that we will start with. Uh, see, I don't know if somebody has a question. I'll try to look at the chat from time to time. If there are no questions, I mean, sorry, if somebody posts a question and I don't look at it for a while, sorry. Um, so I guess what well that installs. Um, I mean, in the README, you can view that the project is very simple in the sense that well, it tries to be super friendly. So the model will be inside a model, and I guess that's the first thing we need to do, and then there's also a trainer. For the trainer, let's see how compatible we can maintain the trainer API. But at least the first part or the first task seems to be okay. Let's just convert the PyTorch code to JAX. So um, let's see. I think the first thing I want to do is I'm gonna keep the PyTorch version in a branch. So uh, that just so I can go back and maybe see stuff or compare to this point in time. So maybe I can check out and just run the PyTorch side of things. So I'm going to just publish this branch as a checkpoint, and I'll go back to master, and master will be the JAX side of things. So okay, I guess we can start with the minGPT-JAX version. So even though this is in the other branch, I'm just gonna keep the folder here for a while. So okay, the idea is to basically translate this. Usually try translating torch and torch to Jackson Flags is not that hard. Uh, and I'll try to keep it as similar as I can to the original code. So so oof, yeah, actually no math. We're not gonna use math. Yeah, we cannot use math, so we have to use everything in JAX. Import JAX, uh, .numpy. Uh, yeah, why not? Uh, yeah, actually, maybe let's just import flex. Flex dot known as n. Uh, let's see. Poetry install. No dependencies. Okay, what happened here? Uh, name. Okay. Uh, packages include. No, please. I don't know what it's doing this. Uh, or maybe it's just do this. Okay. Usually you don't have to do that, but hopefully that solves the problem. VM slash bin slash Python. This is good. Okay. Uh, okay, so um, let's see. Yeah, we got our dependencies. Um, okay, first thing I want to see what this is. It seems to be like a configuration file. So it's probably not something we need to worry about. So that's fine. Um, so okay, the nice thing is that yeah, and then also has module. We don't need to change any of these. And usually support stuff. Um, from PyTorch, we will just be renaming basically. So like this probably just in H is in NumPy. All things will be in NumPy. Okay, yeah, this function pow. What is it? Power. Yeah. Uh, new new yellow. Identical to OpenAI. Okay, let's leave this here. I'm wondering if it's just better to use nn dot g glu, but who knows? So let's not mess with that. Um, okay, seems here we will have to do a couple of changes. First thing, okay, one nice thing here is that we have to split the init into on the Flex side into two separate things: setup and the data class fields, which actually create the true init. So we 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 need to just create like a config field, uh, and then this init will be the setup method, and then there's no config. Something easy we can do is just config equals self.config. But then I'm curious about the type of the config, uh, because it's saying it doesn't have those fields. So let's just try to see if at some point we get the type, or if it's just a dynamic object. Cn. Okay. So yeah, I just want to fix the type error. So, okay, merge from config. So okay, yeah, this is using a little bit of abusing of the dynamic properties um, from Python. Let's see how do I fix this. I think just to get rid of the type errors. Uh, I'm just gonna implement get adder. Uh, and okay, there's a nicer way to solve this. Import typing, and then if type checking. So this method will only be defined when you're doing type checking and you're just gonna write like not implemented error, something like that. Um, so in reality, this will never be called. It's just there to make the type annotations happy. Uh, let's see. Okay. Uh, okay, I need to also probably do the set adder. Def set adder and price. Um, okay. Yeah, not strictly needed, but the type annotations are a little bit annoying. Um, so all of these, yeah, they'll be just unknowns. Um, but yeah, at least we don't see like squiggly lines all over. So okay, back to the important stuff. So yeah, here we're just re-implementing the multi-head attention. Let's see what we need to change. So first thing is just we accept a config and then we just retrieve it. So it's not an input, but it's kind of a field, and it has its stuff. Second thing, uh, here linear is called dense, and we don't need the first dimension. So we just pass the output dimension because we're gonna use shape inference. Okay. Yeah. One thing I just noticed, we're gonna use a dropout. So later we're gonna have to specify some JAX, some flag specific, uh, like patterns around dropout. Let's see, register buffer bias. It wants to register a buffer. So let's see, where is this bias used? Of that bias. So casual mask to ensure that attention is only applied to the left of the input sequence. I'm guessing this is a mask field. So we don't actually need that in the uh, oof. Le- I hope, yeah, we probably don't need that. So what I'm gonna do is I'm just going to assign a field called bias to this, and I think that's kind of the equivalent. So okay, finally some differences. Uh, Here you're getting a view. Mm, okay, uh, black. Let's see. Format. My document. Um, just want to get support for. Well, I guess if I use formatting, I really don't care. Um, that that would create like a bigger diff with respect to the original code. So, okay, what is happening here? We're creating like a view. Let's split this in two lines. Yes equals yes. So we need to create a view. I think this view is sort of equivalent to slicing. Just check. Oh, sorry. Which view? Okay, yeah, it's just a reshape. Shape. Okay, yeah, view is just kind of a reshape. So let's try to leave the original code. Um, okay, we had in two lines because of the brackets. It's more or less like this. Um, is we could do something like this. Okay, not that pretty, but it works. Or we could just do something like this. Okay, that I think that translates this part. And here you're just setting up some properties, some attributes. Okay. Um, size is probably just shape. See attention. Okay. Let's see. Split. Um, so yeah, there is numpy that's split, but I don't know if Jax Jax split, if it is available as a method. So I guess it's not part of the NumPy API. So I'll just do it the functional version. So jmp.split of this array, and then the team. So here it's axis. Okay. So these are just reshapes. good. Uh, I think we can keep using text that array, which is the new stuff. Um, Seems to work very well. So reshape, and then transpose. Okay, yeah, this is a part that gets a little bit interesting. So, so mask field. Uh, we don't have this in NumPy. Let me see if there is a NumPy API for this. Oops. Um, Field NumPy. Yeah, and the problem here is probably the closest, maybe like a where. So we want to set a couple of values to minus inf. Uh, so the zeros, we want to set them to minus inf. Um, so thinking the easiest way to solve this would be via a where, or okay, let's see where. Yeah, maybe something like this. Not sure about the t's. Let me think about this. So this is it's kind of slicing. Slicing t. Mm, okay, let's trust that NumPy will do the correct thing. I think this doesn't even have the correct dimensions. Oh yeah, it does. It's one by one, and then and then these. Uh, okay, so this slicing. So hopefully this is the same size. So when this happens, it's if else it's just the original value. I think this might be the equivalent. Here we use nn.softmax axis. Um, Contiguous. I think this concept doesn't exist in JAX. Then okay, we also exist in NumPy. What does NumPy do? What does this do in NumPy? Change it to changes the data type. Okay, yeah, the views here are different, so we actually want reshape as we've been doing. Okay, I think yeah, it's probably time to address the dropout issue. So the dropout issue is we have to set like a training flag, and we have to pass this to dropout. Uh, so we have to pass it to the deterministic. Okay, yeah, thanks, Copilot. We have to set the deterministic argument. That is kind of the only difference. Let's see, seems. I mean, trusting on the other logic, I'm a little bit tempted to change the ads for dots, but let's see if let's see if it holds. Hopefully, at dot. It's not implemented here. Uh, Search for at. Let's just hope it's the same dot product, else we just use dot. I think that's could do something like q dot or jmp dot and a comma here. Be a little bit better. Um, just in case, I'm a little bit curious. NumPy dot jax dot. I'm just gonna do a little test. curious about this. Um, okay, 16 by 4 by 5, and then x w. I did it. Should 4 by 5 and x should be, okay, this one shouldn't change. So we have two batch dimensions here. So this 4, okay, it's at 10 here. Requires to have same contracting dimensions. Okay, here we have 5. Okay, it does work. Just curiosity, so we can leave the code as it was. Um, okay, self-attention. I mean, yeah, self-attention implemented. I think that was the hardest block. Uh, because the rest should be like just regular blocks. I mean, just composing other blocks. Okay, layer norm doesn't. Okay, let's finish that and let's do the same trick. Configuration. This is setup. This doesn't exist. And we do this. Layer norm doesn't take anything. This, we change all the layer norms. In Flex, we can actually just assign a normal dict. So this is just this. Linear is just dense. And we only need output dimension. So this should be good. And here, what do we have here? We have function. So this function is taking the data. I don't like this. Let's, do I like this? Yeah, maybe. Think it works. So MSDMLP. Mm, okay, interesting. Um, it's just like a mini on the fly data class. Yeah, I wonder what's the purpose of this. Instead of doing a sequential, why is this not a sequential? Mm, do we actually use this? We only use this once. So don't see the value of doing it as a function here. Why is it not done down here? It's a little bit intriguing. Um, let's see if .mlp is called. It's not even called anywhere else. Okay, so I'm gonna do this a little bit different. I'm just gonna assign each of these to a field, and I'm not gonna do this dictionary. Um, I don't see the value. I don't see a value of doing this, and yeah, also the dropout is a little bit different. So I'm going to do this. It feels like it should have been its own mini class. Wait, was that not like a mini class? I guess for simplicity. Let's leave it as is, but we're going to do this here. Okay, so x this and train equals train, and this part okay, yeah, we can still do this. I guess. So just create the function here, and m equals self as a shortcut. Um, let's let's keep it as it was, like self dot, and then m equals self. So it's very similar. But in both cases, we have to pass train equals train train. Um, one second. Okay. So it seems we're good with this block. Minor change was the dictionary. It's gonna a little bit. We're not gonna have the dictionary. Oh, we have to pass train here. Deterministic. Um, and do we need this in any of these? No. No. Okay, no. A bit of changing style there. Here. Okay, this is static method, so we don't have to worry about it. We get the configuration here. So config, then um, same trick. Okay, this model dict again, which is not ideal. Wondering if we can create like a thing that mimics the API. That it could be interesting. Yeah, I think I will do that just not to get tripped over and over by this. So let's class module dict, and then we're gonna accept the dictionary. So dict, I guess, and it's going to be a dictionary, and yeah, I'm not sure if I have to define call. Not sure if I have to define call, but I'm just going to find get attribute and then call um, yeah, maybe something like this would be this is how we're seems that we're using it. Um, but I'm a little worried. Are we gonna get something funny? Let's see how it goes. So let's revert the previous logic. Okay, this is fine. Okay, we assign them to this and we access them here. Let's see the other module big, so the same. Okay, embedding, call embed. And let's see, we have a number of embeddings to the number of features. This seems to be all right. Okay, module list. We can just use a regular list on the flex side. So I'm wondering if we just use a list. Might be enough. Layer norm. Okay, yeah, layer norm. We don't use this. To see how H is used later. It seems to be the blocks. And use bias false. And it always apply a special scale init. Special scales init to all the residual projections. Okay. This part is interesting where we are going to apply a transformation. So some custom initialization, but wonder how we should do this on the flex side. Um, seems to be just initializing with normal. And the bias is with zeros, but that is okay. There's like a couple of options here. Think we can just use the Flax APIs for this, but we will have to translate this later. Uh, let's okay. This is kind of to load a model, configure the optimizer. Wow. Okay, there's stuff that seem to be like not necessary initially. So I'm just going to ignore them. So let's just continue with the forward. The other stuff, we'll have to see how to adapt it. But so, well, mm, xcall and train. Okay, targets is as an optional. So idx target. We need a train flag. A train. I'm gonna pass train false or maybe true is better. Actually, yeah, there's no default arguments. Mr. Cardoso.
Mr. Christian.
Okay, so I advance a little bit,
Mm-hmm.
and I have 40 minutes left.
40 minutes? It's been an hour and five. All right.
Yeah, I have to leave at 6, but
That.
um, okay, so I'm porting the the model from PyTorch to
Mm,
Flax, and it's been mostly yeah like translating the PyTorch idioms, but it's been surprisingly easy.
mm,
And some yeah some tricky things um, that are specific to PyTorch. I try to create the equivalent, like some classes that uh, that they have there. So some special layers, and we are already at the like
cool. I saw that
G.
you're rewriting the code, so I guess that everything from the init it's already solved.
Yeah, so yeah, we're doing this pattern where we well, I'm still missing some things here, but the pattern we're doing is that init we replace it for setup,
Mm-hmm.
and this part um, this part is I guess we have to comment this code. Um, we shall comment this code, but now we're doing the forward. These class methods, we're going to ignore them, and we are here. So okay, device. We don't have device.
Mm-hmm.
Size is shape. So these are the tokens. It seems, and self dot block size. We have block size. Yeah, we do have block size. Mhm. So okay, it seems that these are the positional embeddings. So arrange. Is this even valid? Long.
I don't think because Ajax.
So we're doing a position embeddings. Why is this long? Just flow 32, I guess. And we don't do this. Um, and squeeze is just expanding. Expand things. Expand. What is it called?
Fundings avec S, with S.
And
Oh.
what is it, like this or like this? Uh, Alternatively, this is just none. Let's do this.
jmp.expand_dims with S. Okay.
Yeah, here it says expand the first axis, so we're just gonna use numpy's notation.
You're
No.
following the saying of explicit better than implicit. Just say, no?
Well, and is that autocomplete doesn't wanna
No,
help
it's
us?
okay.
Yeah.
It's okay.
You
So
understand
okay,
this? Uh, so we have this transformer, and let's see what this stuff is.
WT.
Let me just close this and this and this, and can I close this? I cannot close this. So WTE, token embeddings. So this is an embedding layer. Okay, this can just be called like this. That's okay. Positional. Okay, so we're doing
WT.
learned positional embeddings here. It's interesting.
Got it.
Okay, that is fine. Uh, Next, drop. Okay, what is drop?
Transformer dot drop.
Okay, drop out. Okay, this is good, but then we're gonna have to do the deterministic. Thank you.
Mhm.
Mm, okay, for block in transformer.h. Thank you, Kaparthi, for using explicit names. What is? Oh, yeah,
Look
I,
like
I
the help.
know, I know, like layers, blocks, YH, but let's leave it as is. Okay, this is a block in the blocks, H. Very
H.
curious why it chose H. Um, it seems to be mostly fine, but I think block. Let's just do some, I don't know, like a mini hack here. Let's declare block as block. So so we haven't. Okay, we have. Okay, cool. Forgot to do this. Um, yeah. So okay, now it's complaining properly. It's missing the train. So train equals train. All good. What
LNF.
is this? Layer norm. Okay, layer norm. Then and then head.
That's
And then head. We just have a dense. Oh, this like I don't know. This is fine.
should be okay.
Should be okay. Okay, these are the so logits and what magic is happening here?
Get the player norm, the head, and then you get the logic. Can I take a look at the LM head code?
Loss is none. Okay, some trickery where we're calculating the loss in here. Okay, sorry. What do you want to see?
No, you already changed LM head, right? I didn't saw it.
Uh, this I think it was just a dense.
Yeah,
So
yeah. Sorry, yeah, I thought it makes sense.
there's only it. Okay. Cross cross entropy. Cross
Functional
entropy.
F cross entropy.
Okay.
No index.
Ignore index. Okay, this is a little bit PyTorchy. Um,
Technically no, because it's the cross entropy, the functional version of PyTorch.
yeah, I'm just wondering what is the best to translate this. So this is when we have the targets. So I'm just very curious. So we are flattening. It seems we're flattening.
You get the
We reshape. We're reshaping. This looks like a flatten. Yeah, this looks like a flatten. View minus one
yeah,
looks
but
like a
then
flatten.
I don't know what is the second argument for cross entropy, but I also get targets dot view minus one. Yeah, yeah,
I
yeah.
don't,
You need
I don't
to.
like any of this. Eh, oh, I'm tempted to install Optax and just use the cross entropy from Optax. I'm assuming we'll have to see the shapes later.
Hmm.
Uh, but this seems a job for Optax. Uh, else, we try to do it ourselves. It's poetry add Optax.
Input target and ignore index.
So okay,
Specify a target that is ignored and does not contribute to the loss.
I'll add so like that cross. So yeah, so of max cross entropy, I'm assuming uh, let's just try to see the equivalent arch functional cross entropy.
The only weird that I found is that ignore index. They ignore the last element on that.
Yeah, let's see what the ignore index. And by default is minus 100. Ignore index. Specify a target value that is ignored and does not contribute to input gradient. Okay, it's like a max. It's like a gradient clipping.
Those are over the non-ignored target. Note that the ignore index is only applicable when the target contains class indices. Just I know
Defaults to
-1.
minus 100. Specify a target value that is ignored and does not contribute. Target value.
I don't understand honestly because you have the target, you have the class, then you do the cross entropy, and that is the value that you.
Interesting. I don't know. This okay when average size is true. The lowest average over non-ignored targets. Note that ignoring index on applicable. The target contains class indices. I'm just curious why is it negative? Uh, minus 100. Okay. Ignore the ignore index. Not
We're going to have a loss. It's weird because I don't know what is the last index of that. I would I don't know.
so we're just gonna trust this is more or less this. Um, the only thing I'm not sure, um, because we maybe we do this, targets minus one. Okay, yeah, this view minus one. I'm not sure why it's doing this.
Logic view, logic size, logic view, logic size. So and
So this is tree shape and size is just shape. Um, so this is like this, and then for targets, it's just flattening the targets. But the targets, okay, let's flatten the targets.
so you don't have to also.
I'm not sure I'm not comfortable with flattening the targets. Um, because then what happens to the batch dimension? Um, okay, so yeah, let's just copy this for now. It's V shape. So we're just flattening here basically.
Does not does it doesn't make sense for me actually.
Yeah, I'm not sure, but
We are going to take out the car party argument.
just keep it like that. We will probably not get training today, so
Mm,
um, let's just try to see if we can do a forward pass. Not even generate, so we will not be doing generate today. Um,
okay.
Best case scenario, let's just try to load a configuration and see the number of weights.
Okay.
Um, so let's see. There is the trainer. So in the README, there is some code that maybe we can use. Okay, yeah, it seems. So let's create like a test file here. Okay. Um, so let's see, blah, run. Okay. So we have a config. Let's view call. So we don't pass targets. We just need something with shape, like batch and time. And they just have to be integers. So idx equals maybe vertex vertex. Let's do maybe once. We don't really care, and we're just going to do like, yeah. I mean, 32 seems good, and we want like, I don't know, two here, two batch dimensions, and sequence length 10 in 32, and then let's print all that tabulate. So idx and
And then equals false.
oh
I
wait,
know.
sorry, we need the random key. Key equals yes. So random key idx and train equals false. So we don't have to pass the dropout key, and we should get something Python. Okay, yeah. Probably we get all the errors, but
Would you mind moving the console to your right corner, because I think that our video is it's hiding the no. Okay. I don't know, because the video is located on the top left corner, so we cannot see your terminal.
you cannot see the terminal.
Yeah,
Ah,
because
right.
the videos are super the the video streams of us, it's superimposed on the top
All
left corner.
right.
Yeah.
Let's change it to this.
Mm-hmm. Gotcha. So 294, we can comment the whole generate.
Let's just commenting over for now. Okay. Uh,
Transformer WPE position and
this.
values.
It's just. Oh, progress.
At
Let's see.
least not know what's the WPE position.
Hmm. Um, does this have a fixed sequence length? No, probably not. Or does it? Block size. Let's see. Hits. No, well, it should be dynamic. So hopefully you don't have to specify it. Okay, yeah, let's see again what the error was. Integer input type must be an integer or unsigned.
Integer. And we take a look
Post.
at the definition of WPE. Ah,
Oh yeah, yeah, yeah. I
mm.
we did flow 32, so maybe in 32 instead of block. Yeah, worst case we can do like
Of course, yeah. Mhm.
int. Yeah, yeah, obviously. Um,
Typing, Mr. Christian, typing now. 1024, it's a
can
data
I
type.
enter 124 as data?
Data type and
Ah, okay, okay.
can you
This
explain it?
is
Because I don't see it right here.
sorry. Uh, so yeah, this just has to be like a tuple. kind of the only change. Let's continue. Too many values to unpack.
UKV, and probably it's clean split. How does that?
Okay, and embed. I think this does it a little bit differently.
I'm looking at the signature of split, but I don't think that returns.
So I think should be three here in the NumPy world. Um, for a second, um, comment this three here. Let's try it again. Yeah, I think in NumPy you specify as in how many you want to split it. Okay, yeah, we passed transpose
The reshape.
permutation.
1, 2 for operand shape, 2, 10, 12, 64, 2, 10, 12, 64, and then transpose is 1, 2. Why? What?
Okay, I think this is called swap
Uh, hmm.
axis in the NumPy world. Let's look at all the transposes. Transpose. So they do exist, but I think in the NumPy transform. Oh, I have to go soon. Transpose. NumPy transpose. Yeah.
For one-dimensional array, you need.
So you pass like in the NumPy transpose, it's a little bit different. You pass like a tuple,
Hmm.
and you have to specify all the like where everything is going, but swap axis accepts two. So you swap
Hmm.
this one and this one. Okay, transposed. So we'll have to see what is this. Uh, okay. Again.
It went? I know. Dropout.
Ticked.
Yeah.
Ticked. Dropout needs PRNGs. Uh,
Mm.
okay. Not train. Again, please. Woo!
Oh! 163 thousand parameters. I don't know how to say it.
Yep. Okay.
160K parameters. Cool.
Let's maybe maximize this. Okay, so we got all of our parameters.
Mm-hmm.
163 million.
163 million parameters.
Yes. For this configuration, um, let's do let's do something um, which is depth equals 2. So we have a little bit of a summary. Okay, so
Plug, embedded, cool.
yeah, it's a little bit more summarized. Happens at depth one. Uh, okay,
Transformer and the head. Does it make sense?
okay. Let's look at this one. Yeah, um, I'm just wondering. Okay, now let's look at the so. Okay, have to go in 3 minutes,
Mhm.
but um, let's so one doubt I had. So uh, my my biggest worry is that I implemented this module dict
Mm.
simulating some of the things that Kaparthi was doing here, Karpathy, which was just assigning this and then but just using get attribute. The only problem, I just want to check that these layers actually have parameters. So let's search for that because that was my it's kind of my biggest worry with this implementation. Uh, so
There is one more dig, no? With the get attribute, which is the dropout.
okay, I'm very curious why we are getting weird stuff. What is this column?
Output.
Outputs. Something
You're
is
returning a string of the configs. It looks like it's something like that.
no. We're returning a layer. What is this? Oh, it's the module axis. Hmm. Ah, okay. I might need to fix. Might need to fix this.
So I think that let us stop it here before you go because I think
No,
that's nice.
I think we
Mm,
can continue. This is just something funny that I just noticed in the implementation of Tabulate that it's
mm.
speaking stuff from the get attribute, uh, but um, which normally doesn't happen because this is the first time. So this doesn't have like a call, so it's showing it like this. I think
Mm.
the important thing is not actually this one, but that
The return of that.
no the that its inner things do
Mm.
do have layers. So these dens we do have it here, and the other module dict. So we should have a couple of module dicts.
There is another one there. Hmm.
Transformer dict H9. So let's see. Let's copy this and search. How many? So the transformer itself,
It's a molded.
it's a module dict. Let's verify that. Yeah, this
Yep.
whole thing is a module dict. So I think it's working as intended. Um, one thing we can do is compare with the original code, but I have to leave now. But I
Mhm.
think it is more or less with a few uh, things we might have to improve working. So we can leave it at this. And thank you, Mr. Cardoso, for
Mr. Christian, thank you for inviting me. So next session we'll finish. We'll tackle the back, the
yeah. We're just
gradient.
getting started. I think this will take a while. Like I know maybe I even work on it offline, but this
No, but
is
this is
gonna
a
be like
stream.
a little side project I wanted to stream.
But there is a live stream, so don't work it offline because also I would like
Okay,
to,
if I'm
to
gonna
do
work on it, I'll just start streaming and
it.
I'll ping you.
Yeah,
But
and
tomorrow,
throw me VS Code shares, please.
it could be that could be an option in the future. Yeah. Okay.
Mr. Christian,
See
thank you
ya.
very much. Good
Okay.
afternoon. Bye bye.
Bye.